Number 1. Match the graph with its related table. Looking at my graph, you can see this forms a line. That means looking at my tables, the one it would be is the one where it increases by the same amount. The only one that does that is B. So the answer is B for number 1. Number 2, it says graph each set of ordered pairs. Use words to describe the pattern shown in the graph. So these 4 graphs go with A. Notice how all the x values are increasing by 1 and all the y values are increasing by 1. That means our graph is going to be a line. That means it can't be C or D. Now the difference between A and B is the rate in which they're going up. Looking at A, we have 0, 0, 1, 1, 2, 2. So that tells me it has to be A. And like I described, I said both the x values and y values are increasing by 1. So that means I'm going to choose B. Now the second set of coordinates. The x values are increasing by 1, but the y values are decreasing by 2. That means the graph is going down, and it is a line. That means it is not C. Looking at B, we know my first coordinate is 1, 9. Here, my first coordinate is 0, 14, so it can't be B. Let's look at A and D. Starting with A, my first point would be starting at 2 for x. So that means it can't be A, it has to be D. Now, like we described, the x values for the coordinates are going up by 1, but the y are going down by 2, or decreasing, so C would be my choice. The last set of coordinates, we see all the x's are the same, but the y's are increasing by 2. Now, when the x coordinates are the same, it is a vertical line. So that means it can't be B or C. Now, since it is increasing by the same amount each time, it can't be D because we notice, when we make this larger, they're not increasing by the same amount. So your answer is going to be A. And then what statement best describes the pattern? We said x is always 5 and y is decreasing by 2. And that's number 2. Number 3. In the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. Let x equal the number of triangles and let y equal the perimeter of the figure. Now, perimeter is the distance around the shape. So what we need to do is add up all the sides. So in the first triangle, we have 4 plus 4 is 8, plus 5 is 13. Then for the ordered pair, put it in parentheses. You have the x value of 1, comma 13, parenthesis. Now we do it for the second triangle. Add up all the sides, we have 8 plus 10, which is 18. And then we type in 2, comma 18. And for the last one, 5, 10, 15, plus 8 will be 23. So type in 23. And then parenthesis, 3, comma 23, parenthesis. Now it says, represent the relationship using words. So you're going to multiply the number of triangles in each figure by something. What you multiply by is the bottom number in the first shape, so that would be 5. And that is because that is our rate, and that's what's changing in each triangle. You're adding another 5 to it, so that's going up by 5 each time. And you get the total length. The 5s are the top and bottom of the shape of the figure. Now we add sum of the left and the right of the first triangle. In fact, in each triangle, the sum of the left and right is going to be the same, and that is 4 plus 4, which is 8. And that's the total length of the left and right sides to get the entire perimeter. Now, putting that into an equation form, when you're multiplying is your rate. So we have 5x is 5 times the number of triangles, and then we add 8, we're told, so plus 8. Now our graph, it's increasing our perimeter, so that means it's not going to be C, and A is not even a line, so it's not going to be A or C. So now B and D has the X and Y axes flip-flopped. Now, looking at our table, number of triangles, X is going to go 1, 2, 3, 4 is going to be the smaller amount of numbers, where the perimeter is going to be the larger amount of numbers. So that means our X, the smaller number, should be along the bottom. So that means it's going to be D. And that's number 3. Number 4, it says for the table to the right, represent the relationship using words, an equation, and a graph. Then determine whether the relationship is a linear function. Okay, so looking at this table, x's are all going up by 1. Y's going from one y value to the next, you are adding 4 to it. So it is going up by a constant amount, by 4. Now when you add 4 to each one, basically what you would do is multiply your x value by that number because that is your rate of change. So it'll be 4x. So if you pick an x value, say 1, and you do 4 times 1, you get 4. What we need to do to that 4 to get 3 is subtract 1. That describes f. That is 1 less than the quantity of 4 times the value of x. If I choose another one, say 3, I do 4 times 3 is 12, minus 1 is 11. So I'm going to choose f. Then I'm going to type that in. So I have 4x, 4 times x, minus 1, 1 less than that. Now the graph will be a line. That means it's not going to be A or C because neither one of them are lines. D is decreasing, whereas our table is increasing for the y values. So that means it's going to have to be B for the answer. So is it linear? Yes, it is, because we have a constant rate of change. And that's number 4. Number 5. Graph the function represented by the table below. Is the function linear or nonlinear? Well, our x values are going up by 1. The y values are all different. This is going up by 1, this is going down by 8, and so on. So they're all different amounts, so it's not going to be linear. At our table, the first point is 0, 0. In each and every one of our choices for the answer, they all have a 0, 0 point. They all start at the middle. For our second coordinate, though, we have 1, 1. A third coordinate has a point with a negative y value. Both A and C do not have any negative points for y values. So it cannot be either A or C. It has to be either B or D. So let's try B. Okay, so we have, looking at a range, every other dash is a whole number. So 1, 2, 3, 4, and 5. So this is 1. Looking at this is 2, 4, 6, 8, 10, 12, 14, 16. So the y's go up by 2's. So that means this is 0, 0. This would be 1, 1 because halfway between 0 and 2 is 1, and this is x for 1. So then we have 1, 2. We'd have 2, 4, 6. This would be 7. So then we have 1, 2, 3 going up 2, 4, 6, 8, 10, 11, which that does go with our point, so it looks like it could very well be B. So let's try it. It is B. And we clearly see that that is not a line, so it is nonlinear. And that's number 5. Number 6. The cost C in dollars for pencils is a function of the number n of pencils purchased. Graph the function shown by the table to the right. Tell whether the function is linear or nonlinear. Well, looking at the table, we see that the cost of the pencils depends on the amount of them. So x, or the independent variable, is going to be the number of pencils, and the dependent variable, or y, is going to be the cost. So now looking at our graph, you got to see which one it'll be. For the cost, we're going up by 1 each time. For pencils, we're going up by 8 each time. So the rate of change is constant. That means it's going to be a line, so it can't be B, because B is not a line. So the next thing we look at is to see which coordinates would match. We do not have a 0, 0 as a coordinate, but there is one here for D, so that means it can't be D. So it's either going to be A and C. The differences between A and C is the axes. The x-axis here is 0 to 48. Here it's 0 through 10. Looking at my table, I'm going to want my x's to go from 0 up to 48 because it has a larger span for pencils. So that means I'm going to choose A. Now my graph is linear. It has a constant rate of change. Good. That's number 6. Number 9. For the diagram below, the table gives the total number of lines y in the figure number x. What pattern can you use to complete the table? Represent the relationship using words, an equation, and the graph. Now, looking at our table, the x's are going up by 1, the y's are going up by 2 each time. So if you were to do something to each of these to get this one, you would multiply each of these by 2. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So that means my choice is going to be 2 times the figure x. So that would just be y equals 2x. Looking at my graphs, since it is increasing, it cannot be A because A is decreasing. D is not a line. If you look closely here, it is not linear. So it has to be either B or C. So let's make B larger to see what it will be. So we have the x's going up by 1s. 1, 2, 3, 4, 5, 6. Y's are going up by 2s. 2, 4, 6, 8, 10, 12. So here we have 1, 2, which matches. 2, 4, 3, 6. So that matches, so it's going to be B. And that's number 9. 10. The set of ordered pairs represents a function. Write a rule that represents the function. So what we're going to do first to figure this out is to write the coordinates vertically. So 0, 0, 1, 7, 228, 363, and 412. What we're going to do next is see what we add to go from 0 to 7, 7 to 28, 28 to 63, and 63 to 112. The goal is to continually do this until all the numbers we're adding are constant. So we first see what we add to get 7 from 0. We add 7. To go from 7 to 28, you add 21. To go to 63 from 28, you add 35, and to go to 112 from 63, you add 49. So we see these numbers are not constant. That means it's not going to be linear, but put an x underneath it because this represents it being linear because linear functions have an x with an exponent of 1 or just x. Each time we do this, when we go to the right, we add a 1 to the exponent, so the second time will be an x squared once we're finished. And then we'll keep going until everything we're adding is the same number. So now we're going to see what we add to 7 to get 21. That is 14. See what we add to 21 to get 35. And we add 14. See what we add to 35 to get 49. And it is also 14. So like I said before, write that x squared there. And these are all the same. So that tells me my equation will be an x squared function or quadratic. So we start off with y equals x squared. But we're not finished yet, because if you notice, if I substitute one of my x values in for x, say 1, I'll have 1 squared, which is just 1. It's not 7 like I want it to be. So what you do from there is you see what you multiply to this number to get that 7, which would be 7, because 1 times 7 is 7. So now take that 7 and just put it in front of the x squared. So now my equation for the answer is going to be y equals 7x squared. And I can check these. Put 2 in for x. 2 squared is 4. 4 times 7 is 28. Put in 3 squared, you get 9. 9 times 7 is 63. 4 squared is 16. 16 times 7 is 112. So this checks, so this is my answer.